Hello and welcome to section 3.1. Guess what? We're halfway there. Woohoo! We've completed our halfway point. You've done chapters R, chapter 1, and chapter 2 already. And this is now the start of chapter 3. And we just have 3, 4, and 5 to go. So congratulations. Keep working hard. You guys are doing awesome. And definitely don't quit halfway through, because where would you go if you quit and you were climbing a rock and you decided to stop halfway? You can't! So let's do it. In chapter 3, we're going to be working with graphing and understanding how to graph points, how to graph lines, and also trying to come up with relationships of these ideas to real-world situations. Let's go ahead and get started. So the first object that we want to be able to graph is a point. A point is a zero-dimensional object. It has 0D, meaning that there's no length, no height. To define a point in two space, now here I've done a graph. Our horizontal axis is known as the x-axis, and our vertical axis is known as the y. The place where they intersect is known as the origin. So to be able to define a point in two space, we call this two space because it's basically a two-dimensional grid. It's got length and width. So to define a point, we always use two coordinates: the x coordinate and the y coordinate. And so this is probably a refresher for most of you, but we can graph points simply by defining their coordinates. This means to go over 2 on the x and then to go up 3. So you always graph x first and then y. So the point 2, 3 would be located right there. Let's go ahead and have you guys try to graph a few different points. Let me give you 5 points to graph. We'd like you to graph the point -4, 1. We'd like you to graph the point -6, -5. I'd like you to graph the point 2, -4, and the point 1, 0, and lastly the point 0, -10. Go ahead and graph these points. Go ahead and make a little graph in your video notebook and graph these 5 points. Go ahead and pause the video. And when you're done, you can go ahead and push the play button, and we'll check to make sure that you've done these right. Good luck. Okay, we're back. Now, you should have graphed these 5 points. Let's go ahead and work on this one. Again, we always graph the x and then the y. So -4 on the x and up 1. This is where you should have graphed number 1. Then to graph -6 and down -5, that would be this point right here. That was number 2. 2, 4. So we go +2 on the x, down 4 on the y. This is where number 3 is. To graph 4, we're going to go 1 over on the x and no change on the y. This is where number 4 should be graphed. And lastly, 0, -10. So we go 0 on the x, down 10 on the y. This is where number 5 should have been. How'd you do? Hopefully graphing those 5 points went well. The next thing we need to talk about in this lesson is the idea of quadrants. Because we're taking a horizontal axis and a vertical axis, our graph is actually split into 4 sections. This section here, this section here, this section here, and this section here. And because it's split into 4 sections, we call those sections quadrants. Okay, and to label the quadrants, we always start right here, and we work counterclockwise. Hello, and welcome to where we're going to be talking about graphing linear equations. Now, we talked about last section about how to graph a point. For example, if I had the point 3, 2, we'd go over 3 and up 2. And if I had another point, for example, let's go with 4, 0, then we would go over 4 and over 0. Now, whenever you have 2 points, 2 points can be drawn together or linked together with a line. Now, a line is a composite of an infinite amount of points. And so today, as we work on graphing lines, the key will be to find some points and then to connect those points with a straight line. So let's take a look at an equation of a line. I've drawn one up here. Y equals 2x minus 5. Remember, anytime we relate an x and a y with an equal sign, then we are actually creating a line. And to graph this line, we can use what is called the pick and stick method. Bum, 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 bum. The pick and stick method basically states that you can pick any value for x. Just pick a value for x. I'm going to pick 1 just for fun. You then can plug it into the equation. So I would plug it into the equation here for x. I would get 2 times 1 minus 5. So 2 times 1 is 2, minus 5 comes out to be negative 3. And so that tells us that the y value for this value on the line is negative 3. And so then I can graph this. I would go over 1, down 3, and this is my first point on the line. I'm going to mark it here. It's always nice to label your points. 1, negative 3. Good. So we've done that. Now, you've got to always have a minimum of 2 points. You can't create a line unless you have 2 points. And so we can plug in another point here. Let's plug in the number 0. It doesn't matter what point you pick. You can pick any one you want. When I plug in 0, I get 2 times 0 minus 5. 2 times 0 is just 0 minus 5 comes out to be negative 5. And so I graph that. 0, negative 5, and we connect them. That's how we graph a line. Remember, you always got to have 2 points.
And now to see a spiritual application of this 2 points making one line, we're going to listen to a portion of a talk from Tad Arcalister a few conferences ago, and he uses his exact truth to illustrate a spiritual principle.
To help bring this oneness about, the Lord established a divine law of witnesses. Paul taught, in the mouth of 2 or 3 witnesses shall every word be established. The Bible is one witness of Jesus Christ. The Book of Mormon is another. Why is this second witness so crucial? The following illustration may help. How many straight lines can you draw through a single point on a piece of paper? The answer is infinite. For a moment, suppose that single point represents the Bible, and that hundreds of those straight lines drawn through that point represent different interpretations of the Bible, and that each of those interpretations represents a different church. What happens, however, if on that piece of paper there is a second point representing the Book of Mormon? How many straight lines could you draw between these 2 reference points, the Bible and the Book of Mormon? Only one. Only one interpretation of Christ's doctrine survives the testimony of these 2 witnesses. Again and again, the Book of Mormon acts as a confirming, clarifying, unifying witness of the doctrines taught in the Bible. So there is only one Lord, one faith, one baptism.
And this helps define the gospel, why another testament was given to us, why the Book of Mormon was revealed in these latter days. So there's an example of why you need 2 points to create a line, and how to graph a line using the pick and stick method. Let's have you try a couple. Okay, so take out your video notebook. Here are 3 linear equations we'd like you to graph. You can use the pick and stick method to do this. Just create a little XY table. Pick any X value you'd like, and then find what Y value comes out of that. We'll let you give those a try, and then we will check your answers. Go ahead and pause the video now. Okay, so let's take a look here. I'm going to go ahead and create an XY table. And using the pick and stick method, I'm just going to pick a value. I always like to pick 0. 0 is so good because it makes it so easy, because 3 times 0 is 0. I'm just left with negative 1. Again, you can pick any number you want. I'm going to pick 1 here. 3 times 1 is 3. 3 minus 1 is 2. And then I just graph these 2 points. 0, 1. So 0 and then down. And 1, 2, I go 1 over, up 2. And these are my 2 points. Now, of course, you can get more if you want. I could plug in 2 if I wanted. 3 times 2 is 6, minus 1 is 5. So I get 2 and 5. And you're going to see that all of these points line up in a line. And we can just connect them like that. Again, a line is made out of an infinite amount of points. Now, you just need to find 2 to get a good graph. Okay, let's do this next one here. Again, XY table. I'm going to pick a value. I'm picking 0. 0 times negative 2 is 0 plus 4. So 0, 4, that's right there. I'm then going to pick a 1. 1 times negative 2 is negative 2 plus 4. Negative 2 plus 4 is 2. So I get 1, 2. And I'm only going to do 2 points here. You could do more, of course. And connect them. That's interesting. This one goes up from left to right. This one goes down from left to right. We'll talk about that y here in a future lesson. X and y. Let's take a look. I'm going to plug 0 in. 0 times that, it's gone. I get negative 5. Ooh, on this one, I'm not going to pick 1. 1 seems a little weird because I'd get a fraction. I'm going to pick a number so I don't get a fraction. Let's see. 3. 3 times 1/3, that's just 1. And 1 minus 5 is negative 4. That way I avoided the fraction. If you got the fraction, that's fine, but it's a little harder to graph. So I go over 3, down 4, and connect these. Okay, so how'd you do? This is one way to graph a line. Again, we use the pick and stick method. We want to show you another way that's important to use because it helps us find one of the unique features of a line. Let's go ahead and take a look at that method. So whenever doing graphing, there's always two unique points that mathematicians love to find. And that is the place where they cross each of the axes. We call these the intercepts, kind of like football. Interception! We find these, so there's always two. The x-intercept, which is where it crosses the x-axis, which you will see right here. And then the y-intercept, where it crosses the y. So the question is, how do we find these? What's the method in finding these? So I'm going to go ahead and draw up a line, and we'll do an example here. Let's say I had 3x plus 2y equals 12. So this is a line, and we want to go ahead and find the x and y intercepts. To do this, we can simply use this method right here. If I want to find an x-intercept, what I do is I set y equal to 0. So I'm going to go ahead and plug, make y equal 0. And in this case, I get 2 times 0. It just disappears. I'm left with 3x equals 12. Now, if I solve for x, that's going to tell me where my x-intercept is. So I divide both sides by 3, and I'm left with x equals 4. So x equals 4. This is the x-axis. The x-intercept then is right there at 4. Now if I want to find the y-intercept, I'm going to do the same thing, but instead I let x equal 0. So I'm going to plug x equals 0 in for this. So 0 plus 2 times y equals 12. Now 3 times 0 is just 0. I'm left with 2y equals 12. And so I divide both sides by 2. I get y equals 6. So my y-intercept is right there at 0, 6. Now, the cool thing is if you find the intercepts, that can be the 2 points that you needed. Remember, we said we only need 2 points to draw a line. And so if you find the x-intercept and the y-intercept, then that's all you need to do. You can actually find the entire line by just finding the 2 intercepts. If I want to find the x-intercept, let y equal 0. If I want to find the y-intercept, we let x equal 0. Okay, so now it's your turn. Let's give you these 3 problems here. What we'd like you to do for the first 2, number 4 and 5, are find the x and y intercepts. Remember that when you find intercepts, they are points, so you need to label them like points. An x-intercept will be like 5, 0, because you let y equal 0. And a y-intercept will be like, this is for an x-intercept, and a y-intercept will always be labeled 0, and then some number, 3, for example, for the x-intercept. So make sure on these two to find your 2 intercepts and label them as points. On number 6, what we'd like you to do is graph. Find the 2 intercepts and then graph the actual line using those intercepts. Again, to find the intercept, you'd let x equal 0 and then let y equal 0. Okay, go ahead and pause the video, find those intercepts, and on that last one, graph it. Good luck. Okay, how'd you do? Let's take a look at it. The first one, if I'm going to find the x-intercept, to find an x-intercept, we let y equals 0. So when I plug in 0 here for y, all I get is 5x equals 10, because this whole thing becomes 0. 2 times 0 is gone. So I divide by 5, and I find out that my x-intercept is at 2. So I'd write that as 2, comma, 0. Okay, sweet. To find the y-intercept, we're going to let x equals 0. Now when I plug 0 in for x, all of this is gone. I'm just left with 2y equals 10. I divide by 2, and I get y equals 5. And so we would write that as 0, comma, 5. So that's my x and y intercept for that one. On the next one, I'm going to do the same thing. To find an x-intercept, I let y equals 0. If this is 0, then that's all gone. I'm just left with 3x equals 12. Divide by 3 to both sides, and I get x equals 4. So the y-intercept is 4, comma, sorry, the x-intercept is 4, comma, 0. Okay, to find the y-intercept, we let x equals 0. I plug 0 in here. This is all gone, and all I'd be left with is negative 4y equals 12. Don't forget there's a negative here. I divide by negative 4, and I get y equals negative 3. So the y-intercept is 0, negative 3. Okay, how'd you do on those two? It takes a little practice remembering how to write those as points. Again, y-intercepts and x-intercepts are written as points, so you need to write them like this. This is the answer right here. 0, negative 3, and 4, 0. Okay, let's go to number 6 up here. You should have plugged 0 in for x. When you do that, you get negative 9. Then you plug 0 in for y, and you get 3. And so we just graph those. 0, negative 9 is way down here. And 3, 0 is right here. I then would graph these 2 points. A line through those 2 points. Sorry, my line's not very straight. Okay, good. That is the examples there of how to graph by intercepts and how to find your x and y intercepts. Okay, so up till now, we've been used to seeing lines with x's and y's. For example, we had y equals 3x minus 5, or we had 2x minus y equals 11. We're used to seeing lines that have both variables in it, x and y. However, there are some special cases that we do need to talk about. It is possible that we'll only have one letter or one variable in our equation. For example, y equals 5. If we only had y equals 5, what would that look like? So you might want to try to use the pick and stick method. Remember, we said we can pick any value for x that we want. Let's pick 0, for example. Now, if I let x equal 0 and I plug 0 in for x, now you might say, wait a minute, there is no x here. Which is true. There's no x, so there's nowhere to stick 0. So what would y be? Well, y would just be 5. Okay, I'll pick another x. I'll pick 1. Well, there's nowhere to stick it in, so what's y going to be? It's 5. It doesn't matter what value you pick. You're going to get 5 no matter what for y. And so if we graph these, I would get 0 and 5. I get 1 and 5. I'd get negative 2 and 5, and negative 30 and 5. And we find out that we get a horizontal line at 5. The y value will always be 5. So whenever you have a y equals a number equation, you have a horizontal line. And conversely to that, if you have just x equals a number, you have a vertical line. So maybe we can just throw in some color here. Oh, some pink. So if it's x equals a number, you get a vertical line. If it's y equals a number, you get a horizontal line. Okay, so let's have you try 3 more problems here. Take out your video notebook. We'd like you to graph the line y equals negative 2. We'd like you to graph the line x equals 4. And we'd also like you to graph the line 5y equals 20. Okay, go ahead and give those a try, and go ahead and push play once you're ready to check your answers. Don't forget that when you have y only, it's horizontal. When you have x only, it's a vertical line. Okay, so let's see how you did. Y equals -2. Remember, y equals means horizontal. So we're going to have a horizontal line here at -2. X equals 4. That's going to be a vertical line at 4. So I would have graphed it like this. Sorry, my lines are not that straight. You can use a ruler. Sometimes that helps to make them a little better. Now, this third one maybe tricked you up a little. We got to get y by itself first. So I'm going to go ahead and divide by 5. It's a little too weird having that 5 over there. I get y equals 4. So y equals 4. When is y equals? It's a horizontal line. And I would do that right at 4. Okay, great. How do we do? Hopefully you did well. That is the lesson. So again, we learned how to find x and y intercepts. To find an x-intercept, you let y equal 0. To find a y-intercept, you let x equal 0 and then solve. We also showed you that you can graph lines by finding the x and y-intercept, which is kind of nice. You just plug in 0 for x and plug in 0 for y, and that gets you the 2 points. We then showed you there's some special cases when graphing lines for horizontal and vertical lines. Okay, well, that's it for the lesson.